This is the lecture portion of Martin Luther King Day. And I want to start out talking about elasticity. We mentioned it a little bit last week. So we want to know about elasticity of demand and supply. It turns out that there will be other variations. We'll want to know, this turns out to be the price elasticity. Elasticity is all about responsiveness. So in the case of supply and demand, how responsive is demand to changes in price? There's an income elasticity of demand and supply. Well, it's mostly demand because supply curves don't change with changes in income. Demand curves change with changes in income. And there's also, this is in Murnane, a cross price elasticity of demand. So what do these refer to? Elasticity is all about responsiveness. Of quantity to price, of quantity to income, of quantity to change in another price. That's what cross price elasticities are. But the elasticity definition is expressed in terms of percent change. So it's a change in quantity expressed as a percentage. So change relative to the base. Compared with a change, percentage change in price. So this is percentage change in quantity and in price. Now, economists like percentage changes. If you think about developmental psychology, much of what we're interested in is a change. How do test scores change in response to some classroom intervention, right? How do some sort of, let's say, crime change with a change in the price of crime measured somehow by incarceration? Rarely do other disciplines use percentage change. You know, in developmental psychology, an intervention impact might be some change in test scores relative to being in the intervention versus not. So if it's random assignment intervention, you either are assigned to be in the intervention or not. This is usually a 1 if yes, a 0 if no. So the change in intervention status, a 1 unit change is going from a 0 to a 1, in other words, not being in the intervention versus being in the intervention. And what typically happens up here is that we have a standardized change. And let's say test scores. So that's that's delta Q, let's say Q's test scores relative to the standard deviation of Q, right? That's a standardized change. That's just another way of expressing the amount of the change. Economists prefer percentage change. Developmental psychologists prefer some sort of standardized unit change. And of course, a regression coefficient. Regression coefficient is sometimes expressed as a standardized regression coefficient. And that's just change in y relative to the standard deviation of y over change in x relative to a standard deviation of x, right? So all these things are just different ways of scaling change, and economists like to do it in percentage changes. So percentage changes have their advantages, but if you're reading the economics literature, you're going to see a lot of elasticities, responsiveness, kind of estimates based in terms of percentage changes. So let's think about this elasticity. This is the elasticity of demand for some good. If, let's say, if price changes by 1%, how much is quantity changing? Is it by 0.5%? Is it by 1%? Is it by 10%? That's all about responsiveness, right? And typically, elasticity of demand is denoted with the Greek letter eta. And is typically expressed as a positive number. So even though price goes up, quantity is going to go down, right? That's what a downward sloping demand curve is all about. We're going to flip the sign of that. So if an elasticity is 1, in other words, a 1% change in price leads to a 1% reduction in quantity demanded, we're going to say that's 1. 1 over 1 is 1, but we're going to say it's plus 1, right? There are many little confusing things. That's one of them. And the convention is that if this eta, formally it's really the absolute value of eta, is less than 1, in other words, unresponsive, inelastic, then demand is inelastic. If eta is greater than 1, then demand is elastic, quite responsive. And if eta equals 1, then it's unitary elastic. Neither elastic nor inelastic, unitary elasticity. This is just saying that it equals 1. All right, so let's think about what that means. We have a demand curve, a straight line demand curve. Doesn't have to be straight, but let's start out with a straight line demand curve. if straight line demand curve then slope, which is change in this case, price over change in quantity, is constant. Right? If we've got quantity down here and price up here, the slope is going to be the change in y relative to change in x. If it's a straight line, that's going to be the same all the way up and down. But if you think about this formula for elasticity, a straight line demand curve may have constant slope, but it has ever-changing elasticity. And to see that, so we've got delta Q over Q is elasticity, half of the elasticity formula, delta P over P. We do a little manipulation here. That's going to be delta Q over Q times, if we invert and multiply, P over delta P. Which is just going to be delta Q over delta P times P over Q. So where does this get us? This is just the inverse of the slope. And is constant if demand is linear. Right, we said the slope is constant, the slope is change in price relative to change in quantity. Here we're just flipping that, so it's change in quantity relative to change in price, and if that's constant, then that has to be constant too. But P over Q is just, it's the relative amounts of price and quantity. Up here, the price is very high, the quantity is relatively low. Down here, we have a much lower price and a much higher quantity. So that ratio is ever changing as you move down the demand curve. Here's where it's annoying that the convention is to put price over here and quantity over here, because we really want to know about the dependent variable quantity, how much is quantity changing relative to price. So we have to do this inversion, kind of stuck with that. But if there's a straight line demand curve, then the slope is constant, but the elasticity, which is the slope or inverse of the slope times this P over Q, has to be changing constantly, because the ratio of P to Q is changing constantly as you move down the demand curve. So let's think about whether what's the inelastic portion of this demand curve and what's the elastic portion of this demand curve. Just mechanically, the higher the P relative to Q, the higher the elasticity, right? If we're up here on the demand curve, it's pretty high P relative to Q, a pretty high ratio of P to Q. So the elasticity is going to be relatively large. If we're down here, we have the reverse. P relative to Q is going to be lower. Therefore, elasticity is going to be lower. So the inelastic portion of the demand curve is the lower portion. The elastic portion is the top half of the curve, and in fact, the unitary point of unitary elasticity is the midpoint on the demand curve. Now, that seems at odds with how we've been characterizing these demand curves. You know, if we talk about an inelastic demand curve, this is quantity, this is price, this is inelastic. Unresponsive. So if it's a straight line demand curve, how can it merely be inelastic when it's supposed to have both inelastic and elastic portions? Well, if you think about it, maybe this is the relevant price range, but a full linear demand curve is going to go all the way up to the intersection with the vertical axis. And this is going to be the inelastic portion, and this is going to be the elastic portion. And it may be the only relevant portion for the purpose of a problem is the inelastic portion. But you can see all straight line demand curves have to have all three: inelastic, elastic, and unitary elastic. And this one does. And by the same token, if we have a fairly flat demand curve, and we say demand is fairly elastic, given change in price is leading to a big change in quantity. Draw the rest of it. This is really the elastic portion, and this is the inelastic portion. All right, and again, the only relevant portion for the purposes of market analysis, maybe this is about the biggest market you could imagine, then we're going to be talking about the elastic portion. But just bear in mind, all straight line demand curves have both elastic portions and inelastic portions. All right. So what do elasticities look like in practice? The Browning and Tufan book have a few of these listed. And furthermore, they distinguish between short run and long run estimates, right? So how responsive demand is going to be relative to price change is going to depend upon whether, with gasoline, let's say, if you're stuck with your car, it's a gasoline car, you're going to be buying gasoline, even though the price has gone up, right? But if you think about 5 years from now or 10 years from now, you've got a chance to replace that car, maybe we're going to replace with an electric car. So you might expect long run demand to be more sensitive to price changes than short run demand. So with gasoline, these are old estimates, pre-electric car. Short run elasticity of demand is very small. It's close to zero, much less than 1, inelastic. Long run, however, there's a range of estimates going from 0.5 to 1.5. So I suspect that because the electric cars are constituting a larger and larger fraction of the market, but that elasticity in the long run will be even larger now than it used to be. Electricity. Short run, electric charges go up. People aren't very responsive to that. Longer run, there's a lot more substitution possibilities to reduce you can move into a house, it's much more energy efficient, and so forth. So there's a much bigger long run elasticity estimate. Air travel, same kind of short run, long run difference. 0.1 versus 2.4. Beer. There's only a long run estimate here. It's pretty small. 0.8. You may think that there are substitutes for beer, but there aren't substitutes for beer. So anyway, we have estimates for these various things and turn out to be important for policy analyses of various kinds. So let's talk about why that's the case. Okay, let's switch from price elasticity of demand to income elasticity of demand. Income elasticity of demand is going to be a percentage change in quantity, so the numerator is the same, but instead of percentage change in price, we have a percentage change in income, call it I. Same idea. We've got some sort of responsiveness. If this is sometimes denoted epsilon, and you have the same kind of categorization. So epsilon less than 1 is income inelastic. In other words, a 1% change in income is producing a less than 1% change in quantity. An epsilon greater than 1 means income elastic. And then epsilon equals 1 unitary income elasticity. So the same kind of categorization here, inelastic, elastic, unitary elasticity. But instead of talking about a change in quantity relative to a change in price, which is the price elasticity, you're talking about the income elasticity, which is a change in quantity relative to a change in income, which has a lot of policy uses as well. So the book estimates some of these. Your income goes up. These are estimates of eta. Cars are very income elastic. Price drops and demand goes up a lot. I'm sorry. Income drops, price goes up, quantity, no, I'm sorry, all right. So this sorry, this is always positive. Pardon me. Income elasticity is almost always positive. Price elasticity is always negative, so we had to have this switch in sign. But here we've got higher income, more demand for almost everything. It's particularly the case with autos. Income goes up by 10%, and auto demand expenditures goes up by 25%. All right, that's a big change. On the other hand, tobacco is very income inelastic. So your income goes up by 10%, your tobacco expenditures only go up by 6%. Electricity is also income inelastic. Your electrical consumption doesn't change very much with changes in income. Alcohol is more elastic than tobacco is. So if your income goes up by 1%, your alcohol expenditures go up by 1%. So these are just two ways of characterizing the nature of demand, both as a function of price as well as a function of income. The final piece, which is used sometimes, and including in the problem set this week, is the cross price elasticity. So here's the percentage change in Q for a good 1 relative to a percentage change in the price of a different good, right? Good 1. This is good 2. So that sometimes matters. In the example for the problem set, Dick Murnane develops these problems for cross-price elasticity in the context of education, let's say private school and public school. So we can fill these in here. So the cross-price elasticity demand for private schools is a percentage change in demand for private schools as a function of change in the public school price. So if public schools, if tuition goes up by 10% in public schools, is that going to have any effect on the amount of private schooling people demand? And it turns out not very much. That cross-price elasticity estimate is only 0.2, which is saying that a 10% increase in the price of public school is decreasing or increasing, I'm sorry, in this case, the demand for private school by only 2%, 10% to 2%. It's a relatively small response. On the other hand, people at the margin for choosing between public school and private school genuinely are facing that choice. If private school tuition goes up by 10%, public school demand is going to go up by a lot. And the estimate here is 1.4. Which is saying if private tuition goes up by 10%, public demand, the demand for public school goes up by 14%, 10% to 14%. So public school enrollment is much more sensitive to private school prices than vice versa. So that's an example of cross price elasticity. But you can also generate more conventional kinds of estimates of elasticity. Elasticity of demand for private schools and public schools. For private school, it's interesting when you think about which should be more responsive. If price of private colleges, the tuition goes up by 10%, is the response to private school enrollment going to be larger or smaller than the response to public school enrollment from a 10% increase in public school tuition? You might expect, if you think about it, there are a lot of people on the margin of, do I go to college? Can I afford it? I've got a job that doesn't require a college education. There are a lot of people on that margin for making that decision. So if public tuition starts going up, they're likely to be quite responsive. And indeed, the estimate is that they are. Public college tuition goes up by 10%. Public college enrollment goes down by 18%. Right? This is a decrease. It's a decrease for private college, but it's a smaller change. So in the case of private colleges, private college tuition goes up by 10%. Private college enrollment or demand only goes down by 8%. Income elasticity. Again, think about it. If incomes go up by 10%. Is that likely to be affecting more the private demand or the public demand? And as you might expect, with privates much more in demand than publics, if people are getting more money, there's a pretty big response of people trying to move into private colleges. The income elasticity is 1.1 for privates and 0.3 for public. So those are pretty different numbers. They vary quite a bit depending on whether it's a private college or public college. And in the two markets, one for private and one for public education, are sufficiently linked that you get these significant and sometimes important cross-price elasticities. So these are kind of the bread and butter of what economists want to estimate in order to be able to solve some of the problems, like in the problem set for this week. So that's those are elasticities. There are a lot of different kinds, but it all boils down to a measure of responsiveness, and it's all done in this kind of percentage change way, and it's all in the numerator, percentage change in quantity, but it's the denominator that's changing. It's either a change in own price, a change in income, or a change in the price of something else. Okay, so now we're going to move on to the incidence of taxation, like sales tax, and find out that that price elasticity makes a big difference for who bears the burden of a tax increase. All right, let's start up again. Now we're going to talk about, this is an application really of the idea of elasticity. And the question is, who bears the burden of a tax? Consumers or firms? Let's talk about a sales tax for the illustration that we're going to develop here. So you raise a tax on gasoline, let's say, and you don't collect it from consumers, you collect it from the gas companies themselves. Is the burden that those companies bear with that tax increase going to be any different than if the consumers paid? And what is the likely share of that burden? It's not likely to be 100% consumers, 100% firms, but there's going to be some percentage allocation of the burden. And we want to know what determines that. All right, so let's take an example of a sales tax, per unit sales tax. Sales tax paid by firms. All right, this is price per unit. Suppose this is $1 in equilibrium, some demand and supply, and some quantity is transacted. Market's going along happily with no government interference, and $1 per unit price is established here, and there's some quantity marketed in the market here. So what happens, let's say a 20% tax. Paid for by the firms. So to find out what effect this is going to have, ask yourself what's going to change here, right? To what extent will consumers be willing to buy different amounts at different prices? That's not going to change, right? The tax is being paid for by the firms, but the firms, all of a sudden, let's make it a 20-cent tax. Firms, all of a sudden, are going to have their desires to supply different amounts to this market change, because in addition to whatever they were getting before, now they've got to pay 20 cents more. All right. So a supply curve, it used to be they're willing to supply this amount if the price is $1. Now they're not going to be willing to supply this amount unless the price is $1.20. All right, so that is a point on the new supply curve after this tax is imposed. But by the same token, any point along this original supply curve indicates a pre-tax willingness, and that's going to be shifted up everywhere by the 20 cents, right? Used to be this kind of willingness at this price, now they're going to want 20 cents more. So we're going to get this vertical shift in the supply curve because of this 20-cent tax. So what's going to happen? Well, in terms of the new market equilibrium, it's going to shift from the old point, Q1, $1, up to the new intersection point, which is going to be Q2, let's say P2, and that increase in price, you can see, is not as much as the tax, right? The tax brought up the supply curve by the full 20 cents. But in fact, P2 minus P1 is less than 20 cents. Right? Some demand has been curtailed because of the higher price. And the new equilibrium is going to be at a price that is less than the full amount of the tax. Let's say that it's halfway up. Let's say 10 cents higher. So we increase, we impose a tax of 20 cents, but the price only goes up by 10 cents. So economists talk about the burden of a tax as being equal to the change in price, P2 minus P1, divided by the amount of the tax. So by how much did that price change relative to the total amount of the tax? And in this case, this changed by 5 cents on a tax of 10 cents. So 50% of the burden of the tax is borne by consumers, and 50% is borne by firms. So it just happens that there's kind of this equal sharing of this burden. Even though you try to stick it to the firms by requiring that they pay the tax, they're going to capture some of that tax in the form of higher prices. But with these kind of supply and demand curves, it's not going to be the full amount. So in this case, with the drawing, it's around 50%. But it's important to know when is it going to be 0%, right? When is the price not going to change at all? In which case the burden is going to be borne 100% by the firms. And under what circumstances is the price going to change by the full amount of the tax? And that's going to be when this price change equals the amount of tax. This is a burden of a tax for consumers, but 1 minus that burden is the burden for the firms. So really, two sides of the same coin. All right, so let's answer this question. We don't have to draw these straight line demand curves and straight line supply curves. They don't have to have this 45-degree angle. So what happens if they're, so let's start off by just saying, suppose the supply curve is the same, but let's say this is a highly inelastic demand situation. Highly inelastic. We come along, we impose the 20-cent tax. The supply curve shifts up by 20 cents, all the way up and down the line. But now you're going to get a price increase by the full amount of the tax. So if demand is highly inelastic, what does that mean? It means that consumers are kind of stuck paying whatever the price is. And if the price goes up, they're stuck. They're not going to change their demand accordingly. So if the government comes along, taxes firms, and the supply curve shifts up by the full amount of tax, which it always will, the burden is going to be borne 100% by consumers and 0% by firms. The other extreme would be, suppose demand is, this is the new supply curve, that doesn't change. Suppose that demand is completely elastic. All right, this is still Q1. This is the original equilibrium. So now, with highly elastic demand, that means consumers are completely sensitive to what the price is. Suppliers try to raise their prices because this tax has been imposed on them. But there's a reaction by consumers to bail out of this. And they're not going to be able to get away with any price increase, because if the price goes up at all with completely elastic demand, everybody's going to bail out. So in this case, burden is fully borne by firms. Right? Price didn't change at all, 0. Tax is still 20 cents. I got 10 and 5, right, from the original example. That was 10 and 20, but the ratio is the same. But in this case, P2 minus P1 is going to be 0. Price didn't change at all. Tax is still 20 cents. So the burden of a tax on consumers is 0, and the tax is being fully borne by firms. So that's the demand side. What about the supply side? All right, so let's go back to our 45-degree demand curve. But now let's play around with the supply curve. Suppose supply is completely inelastic. So now this tax comes along. It's a little bit strange here because this supply curve is going to be shifting up, but it's vertical. So you're ending up in the same position here where firms are bearing 100% of the burden. if supply is completely inelastic. But the final example turns out to be the most likely one in the long run, where we've got some original situation. Tax comes along, supply curve shifts up by 20 cents, goes up to here, and the price goes up by the full amount of the tax. So this is highly elastic. And in this case, consumers bear all the burden. Bear the full burden of the tax. So these elasticities turn out to be very important. Are they large? Are they small? Both on the supply side and the demand curve, and the demand side. But if you think about it, consumers are more burdened by tax increase when, so burden, of course, is the amount that price is going up relative to the amount of the tax. When either demand is highly inelastic, right? That was the first case we started out with, or supply is highly elastic. That was this case we ended up with, supply being highly elastic and 100% of the burden borne by the by consumers. On the other hand, firms are more burdened when demand is elastic or supply is inelastic. All right, so what's most likely here? This is instructive because in the long run, supply curves are thought to be highly elastic. And it really doesn't make any difference, you know, whether the demand curve is fairly flat or fairly steep. In all cases, you're going to get this price increase that's equal to the full amount of the tax. So in the case of highly elastic supply, it really doesn't make that much difference what elasticity of demand is, because consumers are going to bear the full burden. So the general idea here is that best to be on the inelastic side of the market. I'm sorry, has to be on the elastic side of the market. So if your firm is highly elastic, you're not going to end up paying very much. If demand is highly elastic, then consumers are not going to pay very much. But it turns out then to be very, very important to know what these elasticities look like. And we'll talk about this in more detail later. In the long run, longer run, 5 years, 10 years, supply curves become very elastic. So what does that mean? And again, we'll talk about more detail later. But in the long run, short run difference is whether there's enough time for firms to make decisions about plant and equipment, to make investment decisions, right? And if they have enough time, firms are going to adjust their plant and equipment to produce the lowest cost possible, right? And that's going to be true for small markets, and it's going to be true for large markets. You may get additional firms coming in, but they're all going to be striving for that sweet spot of a technological setup where the costs are as low as possible. And if you have a lot of firms doing that, no matter what the demand is, the supply is going to be a kind of constant cost supply, which means that the supply curve is flat, which means the supply curve is highly elastic, which means that when supply is highly elastic, consumers are more burdened. So the kind of depressing empirical conclusion here is that you can impose a tax on firms and things that you're sticking it to the firms, but a market is going to adjust in ways that will share whatever burden there is of the tax in the form of higher prices. In the long run, for most industries, supply is highly elastic. So consumers are going to bear most of the burden, even though they're not initially paying the actual tax itself to the government. So that's a happy thought. Let's just do one more application of supply and demand here, where it's clearly important to know what these elasticities are. And that's impacts of a minimum wage. So now we've got a labor market instead of a product market. But we still have the quantity price. This is person hours of labor per week, let's say. And if you're talking about the Los Angeles labor market, it's going to be millions of person hours per week. And the price over here, price per hour, is just going to be the wage rate. Now, you probably want to have different labor markets in analysis for different skill levels of workers. So let's say this is a labor market for low skill workers. And now we've got demand coming from firms, right? In a product market, the demand was coming from consumers. And the supply is coming from households. So we're totally switching who's demanding and who's supplying, but the basic analysis carries through, right? Demand is likely to be downward sloping because as a given skill level price, in other words, the wage rate increases, firms are going to be demanding less. On the other hand, the supply curve is going to be upward sloping because as the wage goes up, you're going to have more and more people interested in entering the labor market. So we're going to have this interaction of supply and demand in a labor market setting some wage rate for low-skilled workers, and a certain amount of work is going to be offered to them. All right, so that's well and good, but suppose this wage rate is $5 an hour, judged to be too low, not providing kind of living wage. And in response, so let's set a legal minimum wage. Above what the prevailing wage was. Now, let's confine ourselves to labor market employment where it can be monitored and you can enforce this legal minimum wage. Not worry about complications from people getting tips and so forth. And just think about what is likely to happen in response to the imposition of a minimum wage that's above the market clearing wage. Well, we're likely to have, if that's the prevailing wage, because it's legislated to be, you're going to have a certain willingness of households to supply labor at that higher wage. But on the other hand, it's a higher wage, so firms are going to cut back on their hiring. And the net change here is going to be a reduction. Well, it's going to be a difference in labor demanded versus supplied. Now I say that because this difference from where you started out to where you have the amount demanded by the firms, that's going to be the actual reduction in employment. It's going to be some portion of this total difference, because this amount is going to be the difference from extra worker willingness to work at the minimum wage. So you'll observe a certain amount of a reduction in employment, but that's only a portion of the total effect. The other effect is from people who would have been brought into the labor market at this higher wage, but aren't able to get jobs. Okay, so that's a fairly traditional kind of application of supply and demand, but here's where elasticity comes in, right? Suppose this is quantity person hours. This is wage rate. Suppose demand had been from firms had been very inelastic, unresponsive, and supply was kind of this normal upward sloping supply curve. So if this was the equilibrium wage rate before, and the minimum wage was above that, you originally had Q star in terms of person hours and labor market. Not very straight, but you can see small reductions in employment. So the more inelastic demand is from the firms, the less responsive they are, in other words, to having this minimum wage imposed, the smaller is going to be the employment effect. There'll still be this number of people who weren't working before and who want to work at the minimum wage but won't be able to get it. But in terms of the actual unemployment impact, it's going to be very small if demand from firms is fairly inelastic. So the employment effect which is a huge political argument, right? Should we raise the minimum wage? Well, if we raise the minimum wage, then low-skilled workers aren't going to be able to find work. And this is a general fact about theory. Theory predicts that employment demand is going to fall, but it doesn't tell you how much it's going to fall. That's an empirical question. So employment effect is predicted to be negative but its magnitude is an empirical question. And it's kind of a general point about when you have discussions with an economist. An economist is going to be confident that that there will be a certain direction of an effect of a policy, but the theory doesn't tell you how much it's going to be. It tells you what it depends on. In this case, it depends upon the elasticity of demand, but it doesn't tell you what the magnitude is going to be. So for that, you need to have empirical studies, and there have been many estimating this. And for small increases in minimum wage, the impacts are estimated to be fairly small. The jury is still out on these much bigger increases, like Seattle's up to $15 an hour. But as I say, the important thing here is there's a theoretical prediction that's qualitative, but the quantitative assessment is really what you want for policy purposes, and that's got to come from empirical studies. All right, so problem set is going to be taking you through a number of problems that depend upon being able to work with elasticities. We'll have our usual problem set session on Wednesday, and then class on Monday.